hit record. Sorry. Michaela, you're still there, right? Michaela, can you hear us? It told me Michaela was going to get removed, but I still see Michaela, so we're going to go with it. All right, sorry. We got Aiden, Hannah, John, Jonah, John Vito for 5 people. Let's give it a try. Ready, Aiden, you ready over there? All right, ready. On your mark, get set, go. Uh-oh. John Vito can't. We're going to try that again. John Vito, can you see Jonah on your screen? Kind of. All right. Hopefully you can see Jonah. All right, and John seems like he just lost video there. I don't know what happened. All right, John's back. Can you see?
It's bugging. Everybody's so slow.
Okay, gotcha. All right, let's try it again. Ready? So we're gonna go from Michaela's back. Good. Michaela's here twice. Oh, Michaela, did you freeze? Maybe.
My brother's also in a meeting right now, so our Wi-Fi isn't working, so it wouldn't let me do anything. But I'm on my phone.
I'm sorry. Okay, gotcha.
Yeah.
All right. Let me see if I can remove that one. All right, here we go. All right, Aiden, you're going to start us off again. We're ready. On your mark. We're going up to John Vito. On your mark. Get set. Go. Aiden, no. Oops. Aiden, can you hear me? Did you freeze? Is this a problem with the video? I didn't see Aiden do it. Did any of you see Aiden do the wave?
Yeah, I saw him do it.
You saw him do it. Oh, maybe it's my computer then.
Yeah, it was me. I couldn't see Hannah, but I got it now.
Okay, sorry. Let's try again. I thought Aiden was frozen for a second. All right, ready. Aiden, on your mark. Get set. Go. John Vito was frozen on. John Vito, did you do it? Because you were frozen on my screen.
I did do it.
I trust that you did. All right, I'm going to say that took 6.8 seconds. All right, I didn't anticipate the issue with like some of the glitchiness of this, but we're going to keep trying. All right, now we need 8 people. We'll skip me because I'm not on video, or do you want me to be included? I don't know. Should I do this? Kayla, when it's your turn, click on whoever above you. Lucia, I think. Oh, yeah, okay. So, yeah, Michaela, you're going to go after Lucia. So I don't know if you can see her on your screen, but you are after Lucia. All right. All right, let's skip.
Okay.
Okay. All right, so it's going to go Aiden, Hannah, John, John Vito, and then Jonah left. So, oops. Okay. All right, let's go up to Noah. Yeah, let's go up to Noah. So we'll have 8 people. Noah, can you see Michaela? Okay, you're the last one to go. All right, Aiden, on your mark. Get set. Go. Okay. I'm not seeing everybody do it, but I think it's because they have some freezing issues, and then Jonah joined in midway through. Okay. Let's try it one more time. Sorry. And we don't have to do too much of this if it's going to be glitchy, guys, but the order that I'm seeing that I want to happen is Aiden, Hannah, John, Jonah, John Vito, then Katie. We'll do Katie, Lucia, Michaela. We'll stop at Michaela, okay? Can I get a thumbs up if you guys all heard that good? All right, Jonah, you're still with us? All right. All right, on your mark, get set, go. Aiden. Okay, that was good. So yeah, there was definitely a little bit of glitchiness with the freezing, but you know what? I think it's still going to be okay, guys. I'm going to say with the freezing, we'll call that like 10.8 seconds. We'll take a second off for maybe some of the glitchiness. All right, now we're up to 11 people. So that's going to be Noah, Rachel, and Robert. Robert, you're the last one, okay? Okay, and Rachel's just before you. Noah, you're with us too. We'll start over again with Aiden. Aiden, you have the toughest job to start us off each time. Okay. All right, yes, it's a good stretch in the morning here. So, all right, ready. Aiden, on your mark, get set, go. Oh, that was very good. I saw all of you do the wave that time. So we've got 13.5 seconds for 11 people. All right, so now we've got, we'll say 14. And I think that's kind of perfect because we have 14 of you here. So we're going to go all the way to the end with Zach right now. All right. So it's going to go after Robert, then it's Shane, Tara, and Zach. Tara, can you see us okay? Or can you at least see Shane? If you can.
Yeah.
Okay, I was going to say, if you can see Shane, after Shane goes, you go. All right. All right, here we go. All right, Aiden, you ready again? Okay, on your mark. Get set, go. Wow, guys, that was so good. I'm so impressed by this. It's really starting to take form. Now, I will say that you can also smile while you do this. I don't know if you've ever been doing the wave and smiling, but you seem like you're really pained by having to stretch out and do the wave right now. So let's try it like one more time. And I feel like you really want me in this too. I don't know why, but you really, I feel like you want to see me in this. So we're going to try one more. Can I really challenge us though? All right, well, there's 15 of us. We're going to count this as 30 people. All right, we're going to go around twice. Aiden, you ready for this? So after Zach goes, you're going to start over again. But with me throwing myself in the mix right now, I go after John Vito. So I go, it goes John Vito, then me, and then Katie will go. I'll keep track of the time on my phone. All right. Let's see if we can run through it twice. Thumbs up if you're all good. We're good and ready to go. All right, Aiden, on your mark, get set, go. All right, I didn't see John Vito because he's frozen on my screen, I think. Okay, good. Aiden, good. Wow, that was really good, guys. So that was 30. We jumped ahead to third. That was excellent, actually. Very, very, very good. All right, so let me go back to my screen here. So we're going to say that 30 of us took 35.1 seconds. All right, I'm dying to know what our scatter plot looks like. So if you wrote this down, great. If not, we're going to go right to our calculator and let's edit some lists here. See what kind of data we're looking at today. All right, so the number of people in the wave, that's going to be our list 1. So 3, 5, 8, 11, 14, and then, oops, our last one was 30. And then list 2 is going to be the time elapsed. So we've got 3.4, 6.8, 10.8, 13.5, 16, 35.1. All right, let's see if I can zoom in a little bit on this. You can see that a little bit better. Should probably learn how the Zoom works on this now that I only have a few lessons left to teach here. All right, so we've got that typed in. All right, then I'm going to go to second y equals, make sure my scatter plot's set up. Right now, mine's set to list 3 and list 4 from my video that I did yesterday or 2 days ago. So we've got list 1 and list 2 is what I need there. Hopefully you guys are all set up there. I'm going to clear up my y equals. I have a sinusoidal regression in there. I don't really want that. But without even doing a regression, because we don't really know what type of regression, I mean, maybe you guys have a good idea as to what type of model this is. But if you hit Zoom 9, part of what we're going to wind up doing is on the post for today, which is choose the best regression model, you really want to look at the scatter plot first. And once you've looked at the scatter plot, then make a determination. Does it look linear? Does it look quadratic? Does it look exponential? Does it look sinusoidal? I don't know. And based on this, I was going to say, make the letter with your hand of what type of model you think this is. Although I think a Q would be tough to do. Can you make a letter that would fit this type of model? I don't know. Is that too hard to do? Yeah, it looks like L for loser, but we're going to go L for, I don't know if it's linear or logarithmic, but I think linear sounds like it would make the most sense to me. So, all right. So we're going to go that this is a linear model of best fit. And what will tell us if it's a really good fit? It's that value of R, okay, that linear correlation coefficient. We'll see how good the model is. So I'm going to go to stat calc. We're going to go to option 4 for linear regression. Okay, make sure it says list 1 and list 2. Mine currently said list 3, list 4. I'm going to store the regression equation in Y1. There is an easier way to do that thing by going to that vars, by the way. I think it's alpha trace. Let me see. Yeah, there it is. Alpha trace is a quick shortcut to get to Y1. So if you want to use that, go for it. And then I'm going to hit calculate. Okay, so if we look at our information here, we have the values of A and B for the slope and the y-intercept. Look at that R value, guys. We almost, I mean, we didn't get 1, which we shouldn't get in the real world, but we got 0.9983. That's a pretty strong correlation coefficient if you ask me. So I think a linear model makes a lot of sense for this given set of data, okay? So if you hit zoom 9 again, you'll see the line of best fit if you stored it graphed against your model, and I think it looks pretty awesome. So what we can do is we can use this model, of course, to then make predictions, right? So if I go back and write down what the linear model was, something that you would see if you've watched the sine regression video already, is that if you go out to like the tenths or hundredths place, sometimes even if your R value is strong, the predictions that you make are not very reliable. So I'm going to carry this out to like the thousandths or the 10,000ths place. I'm going to go out 4 decimal places. So the equation for the line of best fit is 1.1439x. I don't know if you guys can see that, but maybe you're writing it down. All right, 1.1439x plus 0.7304. Okay. So what might I ask you based on this line of best fit? Well, what if there were like 500 people in the wave? What if we just kept going around? If you use a cubic regression, the R value rounds to 1. Wow, that's pretty sweet. So Shane brings up an interesting question. If we use a cubic regression, that it would round, that the R value is really great. A cubic regression might look nice, let's say, for our given set of data that we have here. But in the long run, do we think that if I go beyond 30 people, that we're eventually going to have the time dip down like a cubic model might? You know what I'm saying? So think about this in the long term. Shouldn't, as the people increase, the time that it takes increases at about the same constant rate? So although other models in this window might fit it just fine, I think over the long run, linear makes the most sense. Okay. All right. So what did I say? 500 people. How long would that take? Well, number of people was an X value. So if we plug that in for X, 1.1439 times 500 plus the 0.7304, oops, would be about 572.68, and that would be in seconds, right? So if we divide that by 60, according to our model, if we had 500 people, it would take about 9.5 minutes for us to complete the wave. And that kind of makes sense. I don't know, if you think about like a sports stadium, I wonder if we timed how many people were there versus, you know, how much time it took. Maybe we can come up with some similar modeling here. So about 9.5 minutes there. And then, of course, the other question that you might come up with is, you know, if the wave took 10 minutes to complete, how many people were in it or something like that? Well, we just saw actually 9.5 minutes. Let's pick something else. Let's pick like if the wave took us a half an hour, if the wave took us 30 minutes to complete, how many people would be in the wave? Well, 30 minutes, what we have to do is just, first of all, get that into seconds, right? So 1,800 seconds there. And then we're plugging that in for y and solving for x. So you would subtract the 0.7304 to the other side, and then finally divide out 1.1439. So if it takes a half an hour to complete the wave, then it's going to take about 1,573 people to be in the wave at that point. Now, keep in mind, I guess like in a sports stadium, you know, we have a lot more people than 1,573, but we're talking about like everybody in one row goes up at once. And I realize I'm picking up my hands, but you can't see me do that. But I'm doing the wave right now. So, you know, everyone in the same row, we're counting those probably as just like one person almost, because they're all supposed to stand up at once. So kind of interesting here. This is just a fun experiment. I'm so glad you guys joined in on it this morning. If I can guarantee that all of you had M&Ms at home, we would do a fun experiment with M&Ms too. I don't know. I guess I could always, for next week, try and have you all find some M&Ms somewhere. But there's a fun regression experiment with M&Ms that we could have attempted to. So I'll think about that one. But while we are still here, if you guys have any questions for me from anything that you've seen with Unit 19 so far, whether it be something from a homework or otherwise, I'd be happy to answer those things now. And then if not, that's all I have planned for us today. Just talking about a quick wave here. Robert saying bye. Robert, so good seeing you. Thanks for stopping in. Thanks for helping us with the wave today. Bye, Michaela. Good seeing you. See you, Zach. Okay. So yeah, if you guys did have questions, certainly feel free to unmute or just type them into the chat. But otherwise, if you feel like we're good, you're welcome. Thanks for joining, guys. I appreciate it. Thank you so much. Bye. See ya. Oh, I'll just wave under here. Bye.